I'm Peter from the Web3 Foundation, and I'll be talking today about. So the Web3 Foundation has been established to make Web3 happen, or at least help make it happen. And I'll be today talking a little bit about how we think about Web3 more generally, and then how does Polkadot and specifically fit into that picture, and how it plays a very crucial role in our view of in this space. So first question that I think it's worth to like we probably all know the answer to why do we want to build decentralized applications? Again? Yeah, I'm speaking.
It's working?
Yeah? Cool. All right. So why decentralized systems? So, of course, we have a number of different problems with centralized systems. So there is a number of risks. So things like rent seeking, people trying to set very high prices when we all start using a particular system, data breaches when the centralized system gets compromised and our data is leaked, and in general control over those systems that can result in unpredictable behavior. Then there is another point which is also important in those decentralized systems, that we oftentimes those systems make it much easier to get different applications to work together and different protocols to work together. So we have whole stacks of protocols now being built on top of Ethereum and other blockchains, protocols for gathering orders on an order book, and then protocols for exchanges and so on that can be built using those systems. And then, of course, the ownership aspect that also ties in with governance, that we can really build applications where the ownership is distributed amongst the stakeholders or people that actually care about the application or are using it or providing services through an application. And if we think about the applications, those applications really are the applications that have the qualities that we like, and they are usually multi-user, but they have certain qualities that characterize them. So there is usually no single user that is privileged above other users in the protocol design itself. Each participant, the role of them is clearly defined. So if someone else comes in and can perform a given job better, they can replace that person, or it's clear why someone is performing a given role. And usually the protocols are designed in such a way that we don't have to put too much trust in the protocol. The protocol takes care of providing the right incentives and the right mechanisms in order to ensure every single participant the ability for them to participate and provide whatever service they need to provide without taking on any excessive risks. And when we build those applications, we want them to have all those different characteristics. If we do so, we need to make sure that we don't then fall back on any of the protocols that do not have the qualities that we like. So if we, for instance, make use of the blockchain to handle our logic, and then we store files that are crucial to the execution of the application on a centralized file storage system, then we quickly get to a stage where that may be the point of failure of the whole system, and actually the whole solution is relying on a centralized underlying protocol. So what are those different things that we might want from the protocols that power our application? So while they're maintaining those qualities, we need them to do a number of different tasks. So we need them to, let's say in case of applications, we need to make sure that the state machines across all users' devices are properly replicated. So we have proper blockchains that are able to keep track of not only maybe balance transfers, but also more complex logic. We might want to distribute some files. We might want to send some messages that are not maybe recorded on the blockchain forever, but rather can be broadcasted to the network, and then certain participants can take actions on them or not, and they can be forgotten. So even second layer protocols rely on some of those capabilities. So for instance, state channels, they might rely on the blockchain for security, but they might require a messaging component in order for the two parties to interact with each other and then make use of the blockchain for security. So we still need this additional piece in there. And then we need all those second layer protocols that enable us sometimes more scalability, sometimes additional features added, like for instance, privacy on the blockchain. And then on top of that, different APIs, languages, and browsers that actually serve those applications to the users that we are building for when we build those applications. And ideally, you know, we have to keep in mind whatever protocols we rely on when we build a decentralized application. This application has to work on someone's phone or someone's computer. If we rely, let's say, on 100 different protocols and some of them have huge hardware requirements, then there is no way that someone will be able to use them in a decentralized fashion. So kind of if we want to bring it all together, all the different components that we might need, and try to break it down in a neat way, we can come up with this sort of technology stack that we need to build those applications. So it's a lot of different things, but starting from the bottom. First, we have this peer-to-peer internet overlay protocols and computation description language. So, in the first case, we need those. There is different applications of different users. They need to all communicate with each other somehow. There will be different blockchains running on top, or different types of protocols running on top. But we need some protocol that is decentralized in itself that enables those devices to connect to each other and communicate. And we need a general protocol that will support many kinds of applications, because we don't want a user running 5 different peer-to-peer networking protocols on their device. We want one protocol that extends to many different protocols on top. So here we really support the development of libp2p, and this is also the protocol that Polkadot is being built on top of. And we think that this is a protocol, a peer-to-peer protocol that can extend to many different kinds of protocols on top and different applications. Then we need ability for different people to be accountable for the computation that they perform, and everyone being able to re-execute certain computations. So with blockchains such as Ethereum, we have the Ethereum virtual machine that makes sure that every person that executes a given transaction arrives at the same result of that transaction. So if I transfer some balance to someone else, then in the ERC20 token contract, the addition, subtraction, and so on are performed correctly. But EVM has been designed specifically for Ethereum. We need something that is a bit more general. And currently, a very interesting general standard that is emerging is WebAssembly. And this is, again, another technology that Polkadot is making use of, and many other projects are also starting to make use of as a kind of fundamental building blocks for those decentralized systems. Then on top of that, we get to kind of the things that we maybe think more about. So there are the data distribution protocols. So you might know about BigchainDB, for instance, or IPFS that enable people to store larger amounts of data in a decentralized fashion, and then serve that data in their application. But there is also, of course, all the different kinds of blockchains that are out there, like with completely different characteristics. So there are blockchains, some blockchains that are public, like Zcash or Ethereum, some blockchain that are more consortium based, where we don't actually see the blockchain publicly. But there's many different kinds of blockchains that kind of fall into the category of those low-level, low-trust interaction protocols. And there might be also kind of more complex protocols than blockchains. And then we have the messaging. So here, not a lot of work is being done, but you might have heard of Whisper protocol, and there is maybe a few other protocols that are being developed in that spot. Then, on top of all of that, we have many different second-layer protocols. So we have state channels, encrypted storage. Things like parity secret store, for instance, enable you to have secret smart contracts on top of a public blockchain. And then on top of that, we need APIs and languages that enable people to build applications that leverage all those different protocols. And finally, we need some way to serve the application to the user. So now with web applications, we use a browser. Now with decentralized applications, oftentimes we also use a browser, but that is one that is augmented in some way. So there is usually bindings to those protocols injected, so that you can make use of them. But there are also custom-built browsers, such as Status, that kind of integrate a number of protocols underneath. So this is kind of how it looks like. There is many. This is a generic sort of framework for many different kinds of protocols. But one crucial piece. So I mentioned all those different blockchains that we have currently. All the public ones, all the private ones that are currently running. It's currently very hard to build a blockchain. And the main difference between the different blockchains that we have out there is really in either the fact that they are separate blockchains. So, for instance, a consortium chain can be controlled by a consortium rather than the public network. So people, even if they make an exact copy of Ethereum, they want to make a copy because then they control it. Or there is a different state machine. So, for instance, in Tezos, you have the state machine that only allows certain types of state transitions and that are easily verifiable. So basically, by restricting the types of transactions that can be processed and the types of contracts that can be deployed, you can have a bit more security. But the consensus part and all the networking part is not that interesting. It's basically the same as in many other blockchains that are out there. So a very important piece of technology that we've supported parity on is parity substrate. So parity substrate basically reduces the overhead to build those new blockchains. So it provides all the kind of underlying infrastructure in order to then be able to build whatever blockchain you want on top of it. You can think of blockchains that are very similar to the ones that are out there already. So blockchains kind of similar smart contract blockchains that let's say use WebAssembly. But you can also think of blockchains that are much more complex, such as the Polkadot relay chain to be built on top of parity substrate. So that's one important piece of technology. But really, when we have all those different blockchains, we still want to have them a bunch of additional features. So first of all, we want them to be all secure. If we deploy many of those chains and they are running in all sorts of there might be proof of work, proof of stake. Some of them might make a small ICO, then they don't have much security if they run proof of stake. Some of them don't have much popularity with miners, and they can be less secure. So we can make use of all those different blockchains when we build our applications, but they will not be all secure. Second of all, they are all kind of disjointed. So if we make use of capabilities of one blockchain when we build our application, and then we want to make use of the capabilities of another blockchain, it's very hard to make the kind of the logic on one chain interact with the logic on another chain. They are all kind of in their own little pocket. And then we want to be able to run the application from one device. So if you, for instance, want to use privacy of similar to the Zcash blockchain, while not having the overhead on the Ethereum-like blockchain with a general purpose smart contract, it would be very hard to make an application that relies on both of those for a user. So this is where Polkadot comes in, where it provides the common security layer. So rather than just enabling you to create a network of chains that just communicate with each other, it actually provides the security infrastructure for all those chains to be secure, able to communicate, and also enables you to write light clients that will be able to rely on the relay chain of the Polkadot network in order to be able to run on one device that the user has. So now the application can make use of many different chains while running just the Polkadot protocol. And since the security requirements are potentially not as high, maybe there are other requirements, but experimentation could be generally easier. And the protocol itself is adaptable, so it's not there to be forever. It should be adapting together with the network of chains that it's serving. And both the Polkadot and substrate, we hope that they will form a basis for many different applications and protocols to be built on top of them. And we already have different projects that are keen to use substrate or Polkadot for their protocol. And one important bit is to understand is that both of those projects are basically new protocols. So kind of from the perspective of the foundation, we are supporting parity in developing the first implementations and specifications for those projects. But we are already in the process of engaging additional teams that will also develop technology that support those protocols. So kind of to get things done, we need to collaborate on many of those things. So for application developers, they need to be really mindful of the capabilities that they need for their application to run and which protocols will best suit whatever application they want to develop. Not restrict yourselves to putting files or messaging on the blockchain, but you'll probably need to make use of a few different things in order to make it work in a decentralized manner. Browsers need to be extensible to support new protocols or at least support a set of protocols that is comprehensive in order to build proper decentralized applications. APIs and languages the same. We need to make APIs that will enable developers to leverage those different protocols, and hopefully we'll be trying to push that initiative, but work from any API developers is appreciated. And then also higher level protocols. Ideally, they make use of the lower level protocols that we are designing and building, because otherwise we'll be rebuilding them over and over again, and we'll not be able to at the end run them on everyone's device when we actually need to serve the application to someone and for it to be useful to someone. So just as a summary, like what we are doing, we don't, as the Web3 Foundation, we don't do any development. We have an in-house research team that researches a few different topics related to Web3. We do grants and funding for development. We organize workshops with people that work on particular topics. We had workshops on topics like decentralized exchanges. Now we have on-chain governance, oracles, with all the all leading projects that work on those topics. And now we are starting to work on different initiatives to improve accessibility generally. But we really want to work with the teams that actually develop those protocols. So we are not here to impose any particular set of them. And you can find out more about us online. And hopefully Rob in the next talk will outline a bit more about Polkadot and kind of how it actually works. But that's it from me. And if you guys have any questions, I can take them now. Thanks. One in the back.
On that sort of low level component development, when we actually get started, and where would we most recommend we get started helping out to build?
Yeah. So other than low-level component implementations, when will be the time, or how it will be, where it will be possible to get started? So I would say, in terms of the protocols that like Polkadot and Substrate, like there a lot of pretty much all of the developers are in the Riot channels where you can see the discussions, you can ask questions. All of the development is done on GitHub. I think there is slowly things are put in place where you can actually you can definitely test things. You can try to write simple tools that kind of help with things around the protocol. But just following the development of the protocol is good. Like if you just want to build applications, I think you will need to wait a little bit for some documentation and things like that to come out. But helping out with writing documentations, running into errors and then trying to explain them to others is very useful. And there is also other protocols. So I think pretty soon you'll be able to maybe write chains on the substrate. So even if that doesn't plug into Polkadot, and maybe at some later stage it can. Thinking about like working on things like bridging between chains as well, deploying new chains, thinking what kinds of new chains you can domain-specific chains that you can come up with that would work better. I don't know. There's a number of different ways. Maybe you can say what are your interests in the Riot channel, and then we can figure something out. Yeah, Evan.
Might be a dumb question, but what was the logo link?
So that's a very interesting protocol that we think would be a pretty good, interesting candidate for a Polkadot parachain. So it's a protocol that enables transaction level parallelism. So basically, they include this notion of kind of per account validators. That make it possible to process huge numbers of transactions at the same time. So already with their test network, they were doing like 20K transactions per second, but they are still in the early phases of development. And the way their protocol works, it fits very nicely with the Polkadot paradigm. So it could be one of the parachains that maybe doesn't provide the same kind of capabilities as a usual chain might do. It has a bit different security characteristics, but it's very interesting and new, and it will be probably useful for application developers to leverage when they make their applications. Yeah. All right. Thank you for questions.
Thank you, Peter.